Hello, I'm Silver the Hedgehog. You have arrived at the final part now. The two stages which we have left off. Ionosphere. The ionosphere is the ionized part of Earth's upper atmosphere, from about 60 to 1,000 kilometers, or 31 to 621 miles of altitude, a region that includes the thermosphere and parts of the mesosphere and exosphere. The ionosphere is ionized by solar radiation. It plays an important part in atmospheric electricity and forms the inner edge of the magnetosphere. It has practical importance because, among other functions, it influences radio propagation to distant places on the Earth. And finally, the exosphere. The exosphere is a thin, atmosphere-like volume surrounding a planet or natural satellite where molecules are gravitationally bound to that body, but where the density is too low for them to behave as a gas by colliding with each other. It goes out to 10,000 kilometers or 6,213 miles of altitude, thus reaching to the solar system. Thus, we can also determine what the temperature and pressure is. The temperature is varied and the pressure decreases as a result of increasing altitude. How does it work? The atmospheric pressure decreases with increasing atmospheric temperature because, as it warms up, the air expands, it becomes less dense and therefore lighter. You can use this activity, suppose if you have a packet of potato chips. What happens if you have taken them into space? When a sealed bag of chips is taken to higher altitude, then the pressure of the gases inside the bag become greater than the outer atmospheric pressure and apply pressure on the side covering of the chips bag, due to which the chips bag expand. You can discuss it with Amy Rose. Also, don't forget the boundary line mark, such as tropopause, stratopause, mesopause, etc. So now you have learned about the layers of altitudes of Earth. Like, comment, and subscribe now.